Hello, we are Helen and Sung, and we are going to explain about we're going to find the equation of this polynomial function, and also we are going to tell whether this function is even or odd or neither. So let's start. And to start, before we actually solve the equation, we can do some precision by looking at the graph. And by looking at the graph, like we can see that the end behaviors of the graph are both down. So we can conclude that the leading coefficient is going to be negative. It's going to be negative. And also by looking at the graph structure, we can see that the degree is going to be even. This is some predictions that we can make from just looking at the graph before actually solving the equation. So by looking at the graph, like when we look here, we can see that there are two x-intersection -2 and 1. And this from this graph, we can tell two things. The first thing is the zeros. The zeros are the x-intercept. So by looking at the graph, we can know that the zeros are -2 and 1. Also, when we know the zeros, we can find the factors of the equation. So the factors will be x plus 2 and x minus 1. Also, another thing that we can know from the graph is the order of these functions. When we look at the graph, we can see that the graph is touching and turning at both points -2 and 1. So we can decide that we can know that the order is going to be even and it's going to be 2. And so the equation will be y is equal to a, and we need to include this leading coefficient because we don't know the leading coefficient yet. We just know the other factors. So it will be like this. This is going to be our equation, but we don't know the leading coefficient yet. So to find the leading coefficient, by looking at the graph, we can see that there's this point given. This is 0, comma -12. By looking at this point, we can see that we can find an. And this means that when x is equal to 0, y is going to be -12. So we substitute -12 in y and x in 0. So this is going to be like that. It's going to be like this. And we can get an from this. An is going to be -3. So we are going to include this leading coefficient in our equation. It's going to be x plus 2 to the power square minus x minus 1 to the power square. This is going to be our final equation. And we can also expand that. When we expand that, we can get this equation minus this x cubed minus 15x squared plus 12x minus 12. This is the solution of our first part of the question. And this is the equation of this polynomial graph. And Helen is going to take over to answer the second part.
Hi, this is Helen, and now we have got our polynomial functions. We will be looking at the second part of our question. So in our second part, we will have to find out whether our function is odd, even, or neither. Neither is mean neither odd nor even. So how can we know our function is neither odd nor even or odd or even function? So first of all, we have to know the key concept here. So we will have to find out if our function is symmetrical or not symmetrical, first of all. Not symmetrical. Okay. So what does it mean by symmetrical and not symmetrical? So let's look at the figure here, and let's just say that these are two trees. And if we divide one of the trees in half with the line, and if we look at the first side, and if the first side is exactly and directly proportional to the second part of the tree, then we call it symmetrical. But if the two sides are not directly proportional, then we can say it is not symmetrical. Okay, so if our function is symmetrical, then we will get odd or either odd or even function. And if our function is not symmetrical, then we will get neither odd nor even function. So how can we find out if our function is symmetrical or not symmetrical? We will have to look at the key points here. We have to find out f of minus x, and f of minus x is our key point here. So if f of minus x is equal to f of x, as shown in the figure, then we will get the even function. And if f of minus x is equal to minus f of x on the left, then we will get an odd function. But if f of minus x is not equal to f of x, or if f of minus x is not equal to minus f of x, then we will get neither odd nor even function. So let me write down in the long form here. So if f of minus x is equal to f of x, then we will get an even function, and it is symmetrical to the y-axis. And if f of minus x is equal to minus f of x, then we will get an odd function. And we will have to note that it is symmetrical to the original point. To the original point. And okay, if our function is f of minus x is not equal to f of x, or f of minus x not equal to minus f of x, then our functions will be neither odd nor even function. And we have to also note down that it has no symmetrical properties. In other words, it is not symmetrical. This might be a bit complicated to you right now, so let's look at our function and let's find out. F of x equal to minus 3x4 8 minus 6x cubed minus 15x squared plus 12x minus 12. So this is the functions that we have got, and we'll have to find out f of minus x. So in other words, we will be substituting minus in the place of x. So minus 3 into multiply into minus x power 4 minus 6 into minus 3x cubed minus 15 minus x squared plus 12 into minus x minus 12. So we will get minus 3x power 4 plus 6x cubed minus 15x squared minus 12x minus 12. So when we compare it, it is obviously not the same with our original function. So we'll have to say f of minus x not equal to f of x. So we'll have to find out f of minus x now. So this is not even function. Okay, let's look at minus f of x. So we will have to factor out the negative 1 here. So minus bracket 3x power 4 plus 6x2 plus 15x squared minus 12x plus 12. So all the signs change here because we take out the negative 1. So f of minus x is clearly not equal to minus f of x as well. So it is not an odd function. And as I have said earlier, since f of x is not equal to f of minus x, and f of minus x is also not equal to minus f of x, we will have to say our function is, our polynomial function is neither odd nor even function. And we will have to put in our mind that since it is neither odd nor even function, then it has no symmetrical properties as well. So it is not symmetrical. Please. Okay, so there is also another way, a quick way to find out whether our function is either odd or even or neither. So if all the exponents in our polynomial function is in an even order, then we will get an even function. And if all the exponents in our function is in an odd order, then we will get an odd function. And if the order is mixed, even, and odd, um, we can say that our functions will be neither odd nor even. So let's look back at our polynomial function. So when we look at the exponents there, we get 4, 3, 2, and 1. So we can say that it is mixed. It is not in an even order or it is not in an odd order. All the exponents are mixed. So it is neither odd nor even function. So this is the quick way to find out whether the polynomial function is even, odd, or neither. Um, yes. Okay, so this is how to find out the equations of the polynomial functions by looking at the graph and finding out whether our function is odd, even, or neither. So I hope you all understand our explanation, and this is at the end of our video presentation. And thank you very much.
And thank you for listening, everyone.
Thank you, and bye-bye.